Welcome to 2.3a, real zeros of polynomial functions. Today we're going to be looking at zeros of a polynomial function. So just a reminder, a zero is where your graph is crossing the x-axis. Another word for that is zero, solution, root. There's a lot of words that can be used to describe those points, and that's what we're going to be looking at today. It wants us to actually divide it, to actually factor it completely. And so we're going to go ahead and write this out. 6x cubed minus 19x squared plus 16x minus 4 divided by x minus 2. And so we're going to actually do long division on this. So we're looking at how many times does x go into 6x cubed? What do we need to multiply by so that we could get 6x cubed? The answer would be 6x squared, because 6 times x is 6x and x squared times x is x cubed. So now what we do is we multiply this through just as if we were doing long division. So we write 6x cubed, and we do it here too, negative 12x squared. And just like when we were dividing, we will subtract both of them, which changes the sign of each value. So these cancel off. Negative 19 plus 12 is negative 7x squared, and we bring the rest down. So now we're looking at what do I need to multiply x by to get negative 7x squared? So the answer to that would be a negative 7x. So we get negative 7x squared. We also multiply here, we get positive 14x, and we go through and we change the signs because we are subtracting. So these go away. 16 minus 14 is 2x. We bring down the minus 4. So how do we get x to get to 2x? Well, we add 2. 2 times x is 2x. 2 times negative 2 is negative 4. And we subtract to change our signs here. This goes away, that goes away, and I actually have this divided. And so now it says use the results to factor the polynomial completely. So we already know that we have the factor of x minus 2, and we want to see if we can factor the rest of this. We have 6x squared minus 7x plus 2. That's what we got when we divided it. We know this is a factor because it went in evenly. We had no remainder here, and this is what we have left. So then now you can factor this whatever method that you like to do. The method I like to do, I like to multiply this term to the end, and then whatever I get, I'm going to have to go back and divide by. So x squared minus 7x plus 12 is what I'm factoring, but I know I'm going to have to go back and divide by that 6 to undo that multiplication there. So I'm going to get a 4 and a 3 to equal 12, and that's going to also add to give negative 7. And I remember to go back and divide by that 6, and I have to simplify this because I can't just leave them in fraction form. And if you have a different method to do this, that's totally fine. This would be 2/3, this would be 1/2, and then I do my bottoms up. 3x minus 2, bottoms up, and 2x minus 1, bottoms up. And so there is my factored form of this equation using long division. Let's do another one. 8x cubed minus 1 divided by 2x minus 1. So the thing that we have to be careful with is this has some terms. Where's our x squared? We don't have any. Where's our x? We don't have any in our minus 1. We have to put zeros in those places. Otherwise, this is going to make a really big mess for us because we don't actually have those values there, and so they still need to be there as placeholders. So let's see, how many times do we get to get 8? 2 times 4 is 8, and we need 2 more x's to make 3. So I get 8x cubed, and what do I get here? 4x squared times negative 1 is minus 4x squared. See why we needed that placeholder there? Because we're still going to get a value there. So we change our signs to subtract it. We get 4x squared, bring down what we have, plus 0x minus 1. How do I get to 4x squared? I add 2x. 2x times 2x is 4x squared minus 2x. Now I go through and I change my signs. This goes away. 2x minus 1. What do I get to 2x? A 1. 2x times 1 is 2x. And then when we are in 1 times negative 1 is negative 1, we change our signs and we get 0, remainder of 0. So this is what we have here. So this one just wanted us to divide, but let's take it a step further and see if we could factor it. We may not be able to, but let's see. So we know that this was factored with the 2x minus 1. That was what was out front. If I multiply this through, I'm going to get x squared plus 2x plus 4, but I'm going to have to go back and divide by that 4 that I multiplied through. So I would get x plus 2, but I'm dividing both of them by 4. So I get 2x minus 1 times, this is going to be 1/2 and 1/2, so I do bottoms up. 2x plus 1 and 2x plus 1. And this would be my factored form. I could even write it as 2x plus 1 squared. There we go. Okay, whew, long division. Let's do one more. So long division is definitely a little bit more work. So let's see, what's the matter with this one? It's kind of out of order. That's another thing when we're doing long division, we need to make sure that it is actually written in order there. So we're going to rearrange this. It should be 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. So we want it in descending order of powers. We want the biggest exponents first. X squared plus 2x minus 3 is what we're dividing by. And so how many times do we get to do this? Well, 2x squared would give us 2x to the 4th. 2 times 2, 1 is 2, and x squared makes x to the 4th. So let's go ahead and multiply it through. We have 3 terms to multiply through here. 2x squared times 2x would be 4x cubed. 2x squared times negative 3 would be negative 6x squared. And now I go through, change my signs to subtract them. These go away, and this just gives me x squared plus 3x minus 2. I bring those guys down. So now, let's see, I have an x squared, so I say plus 1. So we get x squared plus 2x minus 3. We subtract, we change our sign. This goes away. 3x minus 2x is x. Negative 2 plus 3 is 1. So I have this remainder of x plus 1. So what my answer would be 2x squared plus 1 plus, this is actually a remainder. This x plus 1 is still being divided by this value. So I write my remainder over what we divided by because it's still a fraction of it because it didn't go in evenly. But there was nothing else we could do to divide it because there's nothing that we could multiply x squared by to get us x. So it's still just that fraction value. And that's as far as we could go for dividing it. All right, synthetic division. So after all of this, you're going to love synthetic division because long division, it's just you're doing the same process, but synthetic division allows us to get rid of some of those x's and just make it a little bit simpler. And so what we do is we're actually going to take whatever that value is of the 0, and we're going to plug that in there. So, and we're going to use the coefficients here. So I'm just going to rewrite this first as we would if we were going to do long division. I'm going to get it in order, make sure that we have placeholders for all of our values. So this is the set of numbers that we have here. What's imaginary in front of that x is a 1. And so these are our coefficients of what we're doing. So for synthetic division, we're going to set up a little bar, and I'm going to put all of these coefficients right there. So I'm just copying these down as if there was no x values there. I'm just writing the coefficients so that we can just do this a little bit simpler because sometimes the x's make it a little bit crazier. So the only difference to synthetic division at first is that we're going to take, instead of dividing by x plus 3, we're going to divide by the 0 here. So since this is the factor x plus 3, the 0 would be negative 3. Negative 3 plus 3 is 0. So whatever solves this to make it 0, that's what we put in this box. And then we set up our division line. So the first step is we just drop the first number every single time. Bring that 1 down. And now what we're going to do is we're going to multiply to this number here. 1 times negative 3 is negative 3. And we just go straight down. We add them or subtract them, whatever it is there. There's no changing of signs. 0 and negative 3 makes negative 3. So now we go over here and we multiply. Negative 3 times negative 3 is 9. We just go straight down. Negative 10 plus 9, negative 1. Negative 1 times negative 3 is 3. And negative 2 plus 3 is 1. And then now we go to 1 times negative 3 gives us negative 3. 4 minus 3 is 1. So now we can actually rewrite this as a polynomial. So we started with x to the fourth, so this drops it because we divided one out. This becomes squared x, our value, and then this is our remainder. So do you see how it just shifted over? So whatever value we started with, it goes down one. So we could rewrite this as x cubed minus 3x squared minus x plus 1 plus 1 over x plus 3, since that's what we were dividing by. That was our remainder. And that's all that there is to synthetic division. So that one's a little bit simpler. On your homework, there's going to be synthetic division and long division, so make sure that we're knowing how to do both. So remember long division, when you're subtracting, you change the signs. Synthetic division, that sign change is happening because we did this first. So you don't change signs anywhere except for the 0, plugging it in. So long division, you put in exactly what you're dividing and you do sign changes as you're subtracting. Synthetic division, you do the sign change only with the 0 and then everything else stays the same. Thanks for tuning in, guys.